Hello, welcome to the video. This is a really cool video series that I'm making, and it is all about using this guy right here, the Raspberry Pi Pico W microcontroller. It's all about learning to use it and make some really cool stuff. And what makes this series of videos different from all the other videos about the Raspberry Pi Pico W out there, we are going to do it all without writing a single line of code. We're going to let AI do the coding for us in this series of videos. You know why? Because I've used AI enough now to write code for me that I know that I will never put in enough effort to be as good of a coder as AI is right now, and it's only going to get better. So I know there's probably a lot of people out there that are like me. You have some other job, and you want to play around with these as a hobby. You don't really want to get into the code that much, but you still want to be able to build some stuff, and that's what we're here to do in this series of videos. We're going to learn how to make really cool stuff without having to learn how to be a computer scientist. And we can do that. I'm telling y'all, we can do that. So the first thing we're going to need to do is whenever you get a new Raspberry Pi Pico or Pico W, we need to put MicroPython on it, because it doesn't have any code on it right now, and for us to be able to upload code to it and run our code, our MicroPython code that we make, or actually that we get AI to make for us, I should say, it has to have MicroPython installed on the board. So that's the first thing we're going to do, and we're going to get started with AI right away. We're going to ask AI how to do that. I just got a new Pi Pico W, and I need to get started. What do I do first? Great choice. All right. Download the firmware. Get the latest MicroPython firmware for the Pico W from here. Okay. We're great. It gave us a link to raspberrypi.org page, and this is going to tell us exactly what we need to do. So the first thing I will mention is that the cable that you use to plug into your Raspberry Pi, if you have trouble with it, I'm telling you this because I wasted about an hour of my life with this. If you do have trouble getting your computer to recognize your Raspberry Pi, there's a chance you might not be using a cable that carries data. A lot of these micro USB cables are only for charging. But this needs to have data and charging. You need to provide both for it to work with the Pi Pico. So if you get stuck here, that could be the issue. So it says to connect the small end to the Raspberry Pi Pico W. I have the other end of this cable plugged into the computer already, so I'm going to do this a little different. But suffice it to say, what you need to do is you need to hold down. There's a button right here on your Pico W. You're just going to hold down that button as you plug it into your computer. And then if you do that, and in my case, I'm going to look at the Finder. That's where mine will show up. You'll see this RPi-RP2. In my case, that is the Raspberry Pi. So it is connected. It is connected to the computer. And now we need to go download the firmware to put onto the Pi. Did they give us a link to that somewhere? Oh, it's right here. Here we go. And we're downloading it now. And I'm going to open our show in folder And then I'm just going to drag it over to the Pi. And then we'll see MicroPython transfer over to the Pi Pico right here. And it's done. And then when it is done, the Pico is going to disappear as a drive. It's not going to show up as a drive anymore. So now we need to go download Thonny. Thonny is the IDE that we're going to use to write our code and upload our code and access the files on the Pico. So we're going to download the Mac version in my case. And I'm going to run that and install it. Okay. Okay, and now we should be good to go as far as all the setup stuff goes. It's actually pretty quick, huh? Now we just want to run Thonny for the first time. And you'll see there's at the top here, that's where the code goes. And down here, this is the terminal or the shell. There are also some other things that we can use here. We'll talk about that stuff later, but let's go ahead and get started. So let me hide this. One thing to note is you see this little area right here. This is where you choose where Thonny is going to run the code. So if you do local Python right here, and I said we're not going to write a hello world program. It should take it in context. It does. So it wrote the hello world program for us. We're going to go back to Thonny. We're going to paste it right here. And then depending on where, which one is selected here, we could run it on the local Python, which means it's going to run on the local computer. And we hit play or run, you can see it runs it down here in the terminal. Now, if we select our MicroPython Raspberry Pi Pico right here instead, and now you can see this changed. Now, whenever we hit run, it's going to run it on the Pico itself. So the code's still here and the output's still here, but the code is actually getting executed on the Pico. Okay, so let's actually get some code running on the Pico itself now. So what I'm going to do, well, first of all, let's take a quick look at, we're going to come back to this again and again, the Pico pinout. It's always good. I keep mine handy anytime I'm working with it. I have one on paper. This actually comes with the Sunfounder kit, which I bought. And I do recommend. There's a link down below. It's got a Pico W and a whole bunch of cool stuff in it. A whole bunch of cool components. Pretty much everything we use in this series of videos is going to come from that. And yeah, if you look at the pinout for the Raspberry Pi Pico, you'll see there is an onboard LED. And you'll also see it says GP25 here. So what we're going to do first is we're just going to make the Pi blink that LED. So let's tell Copilot I have a, I'll say Pico W, and want to blink the internal LED off and on at 1 second intervals. Okay, and the code is ready, and it sets up the LED up here. It sets up the pin as an output here, and then it writes it high. It waits a second, it writes it low, it waits a second. So that should be a blink. We're going to copy that code. We're going to go back to Thonny. And we're going to paste it in, and let's give it a run. And might be kind of hard to see, but yeah, y'all should see that LED is blinking off and on. And what I normally do, just really every time I do any kind of project, I always get AI to refine it some. So I'm going to say make it a 1/4 second instead. And it'll regenerate that code. It changed these values here and here. We didn't write any code. We're not going to write any code. But we are going to be copying and pasting a ton of code. And we'll hit run, and you can see the blink got faster. Now there's one more thing we can do. So far we've been running this code from Fani. Fani sends it over to the Pico, and the Pico runs it. But what if we don't want to use the computer? What if we don't want to be tethered to the computer, and we still want to run the code? Well, we need to save it. And to save it, you can just click the little disk icon here, and you can choose whether to save to the local computer or to the Pico. We're going to choose Pico. Oh, it's busy. Okay, if that happens, you just need to hit stop. It'll stop running the code that it's currently running. We'll click it again, and you'll see we already have some files here. I'll go ahead and I'm going to delete these. Matter of fact, we'll delete everything. We'll have a clean Pi, just like you probably have. Okay, and the point of this is we're going to save this code to the Pi Pico as main.py. If you save it as main.py, then that means that whenever power is applied to the Pico, and you're not connected to Fani, and you apply power and it boots up, it's going to immediately run whatever is on main.py. So we're going to save that now. So what we should be able to do now is we should be able to close Fani, unplug the Pico. Let's blow this sucker up a little bit. And then whenever we plug it back in, we are going to be plugging back into the computer, but the computer is just going to be providing 5 volts. That's all, no data. Plug it in, and immediately it starts running that code. Anytime, and if you lose power and then you get power back, it starts running that code again because it runs whatever is in main.py. One other thing I want to talk about in this first video is this thing that the Pico is actually connected to, a breadboard. And we're going to be using this entire set of videos. So it's important that you understand how the breadboard works. I do have one. I have a web page pulled up here, elicro.com, how to use a breadboard for beginners. Kind of gives you an idea of exactly how it works. So if you look, you see these green lines where it's green. That means that all of those are electrically the same. They're all connected. So if I connect something up here and I connect another thing up here, those two things are going to be tied together. Okay. Now that connection is, if you notice from that picture on the web page there, it does not extend across this middle part, this valley in the middle. That does not make a connection. Now, you also will see these red and blue lines running down the sides. That means that these are all connected all the way down on both sides. Now, this side is not connected to that side, but it's connected all the way down. That's the power and ground rails. And what you can do is you can jump a ground over from your Pico to the ground rail, and then over here on this side, you can, whenever you need a ground or you need voltage, you could just connect here instead of having to run all the way back over to the Pi with all of your wiring. So that just makes it convenient. If we look at our if we look at our Pi right now, and we look at our pinout, let me go back to the pinout here. What I want to do, I want to go ahead and connect the ground rails on both sides now, because I know we're going to be using them a lot. And so I'm going to orient it to where it makes sense to me looking at the, let me see if I can make it make sense to you too. The camera's turned kind of funny. But what we want to do is we want to connect to this ground here, which is physical pin number 38. And we just want to run that to, so we go 40, 39, 38. And we just want to connect that to the ground rail with a little piece of wire. Or you can use a long wire if you want, but a small piece will be a lot easier. So now we have this ground rail is active all the way down that line. And often we'll use it on both sides. So we also have a ground on pin 3 right here. I'm going to go ahead and connect that now too. 1, 2, 3. And I'm going to go to the ground or minus side there. And we'll just push that in. So now the grounds are, they're active on both sides. And we're going to use grounds in just about every project. So go ahead and get that ready now. Another thing that we're going to talk about, LEDs. So LEDs, you have to apply a negative volt to get them to light up. You have to apply ground or negative voltage to the short leg and the positive voltage to the longer leg, and that'll make them light up. So another thing that you need to know about LEDs is you always need to use a current limiting resistor with them. I think this is this is either a 220 or a 220 ohm or a 330 ohm resistor. I can't remember which. I think it's a 330. But we're going to go ahead and put our LED all the way across these two here. And we're going to put the long leg on this side here. Okay. And the short leg, we're going to bring to ground, to the ground rail, but we're going to use our resistor to do it. And that's going to limit the amount of current that flows through the resistor. And if you want to know more about that, I'm not going to go very deep into those kind of topics. If you want to know more about that, you can always just go to Copilot. Why do I need to use a current limiting resistor with an LED? And you can find out right there. So that's one of the really good things. You go down rabbit holes when you start talking to AI, and you learn that way. Okay, so we are going to connect. It doesn't really matter. All of these GP or general purpose I/O pins are digital pins, which is what we want. We just want like 3.3 volts getting sent to this LED for the purposes of this program. So we're going to go to GP16, which is right here on the corner. And I like using the corners because they're easy to spot. So we're going to plug in there, and then the other side, we're going to go to the long leg of our LED. Okay, and so now what we're going to do is we're going to go to Copilot, who gave us all kind of formulas and everything. Okay, I have an LED attached to GP. Where did we say that was? It's right here, GP16. I usually like to talk to AI in terms of GP and not physical pins. It's GP16 physical pin 21. So to GP16, make it blink at 1 blink off and on at 1 second intervals. Okay, it spits out the code, and this time you'll see it set it up as pin 16, which is good to see. We just go to Thani. Oh, and we have a problem here. We're not plugged in. And when you plug in, if you find you have, oh look, it's running that, it's automatically running that code. If you find you're not hooked up, a lot of times, like if you're not connected to the Pi, I just come down here and click this again, and boom, we're connected to the Pi. And you'll also notice that the LED stopped blinking too when we did that, the internal LED. So now we're just going to go ahead and run this code. And you can see the LED here is blinking at 1 second intervals now, instead of the other one. So I think that's going to be it for this one. We got everything set up. Hopefully, we got code running on the Raspberry Pi. We talked about if you name it main.py, it'll automatically run whenever power is applied. And then we also got a simple external circuit working. I think that's going to be good for this one. I'll see y'all in the next one. Thanks so much for watching. Bye, y'all.